Assalamualaikum and hello everyone. We are from group 6 and I will be presenting about question 1. So for our group 6, this is the function that we need to solve for the question 1. Moving forward, okay. So for the first part, we need to find the derivative. Since our function given here is a product of two terms, we use the product rule. I've written here the product rule. VU prime plus UV prime. So we separate it here. This is our U, this is our V. So we differentiate the U and the V like this using the power rule. And then from the power rule, and we get this, and then we can finally insert all the value in the product rule formula like this. So we solve like usual. Here I remove the 3 because it's the common in the numerator and denominator, and then we finally get the simplified answer like this for our first derivative. And then next, okay, we want to find the critical number. So we look for when the derivative is 0 or undefined. Setting our numerator to 0, we get x equal to 0. And then we set the denominator like this, equal to 0, and then we solve it separately like this. We solve for x and we found two values for the x. We get x equals to 1 and then x equals to -2. Therefore we get the critical numbers for the fx are x equal to -2, x equal to 0, and x equals to 1. Okay, so moving to part B, we determine the relative extremum using the first derivative test. So we divided the domain into intervals like this based on our critical number that we get earlier. So I've written here what critical number we get from the previous in A. So this is our interval. So this is our table of sign for first derivative. So this is our interval, and then this is the test point I use based on this interval. We choose test point like -3, -1, 0.5 and 2. So for the interval -2, 0, the sign is negative. Therefore the graph is decreasing. For all other intervals, we can see that the sign is positive, meaning the graph is increasing. Because the sign changes from positive to negative at x equal to -2, we have relative maximum at -2 to 0, and then at x equals to 0, the sign changes from negative to positive. So we get the relative minimum at 0 to -1.587, and lastly at x equals to 1, our sign stays positive, so there is no extremum here. Next, for the part C, it is based on the sign table of x of the first derivative we constructed here in part B. So this is the function that increasing interval negative infinity to -2, 0 to 1, and 1 to infinity, because the derivative is positive. The function that decrease interval only on the interval -2 to 0, because the derivative is negative. Okay, so next for the D, we want to sketch the graph accurately, so we need to find the concavity. So to find concavity, we must find the second derivative. So I write here the first derivative. We want to sketch the graph accurately, so we need to find the concavity. So to find concavity, we must find the second derivative. So I write here the first derivative that we get earlier. So we need to apply quotient rule to our first derivative here. This is the formula for the quotient rule. VU prime minus UV prime over V squared. So the numerator will become our U, the denominator will become our V. So here I differentiate the U, our X we differentiate become 1, and this is the V part. This V part I use product rule. To solve for the derivative for the V, and we finally get here for the V prime. So this is after we get all that we needed, we can enter in the quotient rule like this. It was a bit complex, but in the end we finally get answer like this. So we need another test sign table for the second derivative, because we want to get the concavity. We found that the graph is concave up here before x negative to 1. It become concave down after around here. So because the concavity changes from up here to down here, so this become our inflection point. Here I've written at x equals to -2, concavity does not change because it went to concave up, it stay concave up. But at x equals to 1, the concavity changes from concave up to concave down. So at x equals to 1, we insert in here, and we get our inflection point 1 to 0. Finally, this is the summary of the graph behavior. To make it easy for us to do the graph lah. So this is from our first derivative. This is the monotonicity. This is the second derivative we do earlier, and this is our concavity. And in the end, this is the graph we get. This concludes my presentation for the question 1. Thank you.
Okay, for question number 2, first we are given a rectangle with a fixed area of 50 square inches, and the area of a rectangle is given by the formula. This area equal to x multiply with y. So we can write like this: x multiply with y equal to 50. So from this, we can express y in terms of x. And we are also told that x is increasing at a rate of 2 inches per second. So dx over dt equal to 2 inch per second. And next, we want to find how fast the perimeter is changing. So this one, perimeter. The formula for the perimeter of a rectangle is like this: perimeter equal to 2x plus 2y. So to find the rate of change of the perimeter, we need to differentiate perimeter with respect to time. So dp over dt for the parameter and just differentiate like the basic one. So now we have for the in this equation, the parameter equation, we already have the dx over dt value here, and now we need to find dy over dt, this one, to solve this. So we start from x, y equal to 50. So we need to differentiate both sides with respect to time. Yes, this one by for this side we need to differentiate it by using product rule, and this side just differentiate by using the basic differentiation. So after we solve this, we can get that the final equation, x multiplied with dy over dt and plus 2y equal to 0. So for this one, we solve this to get the only for the dy over dt. So we get this dy dt equal to negative 2y over x. Okay, so next we substitute the dx over dt and the dy over dt into the parameter formula. This one, the parameter equation. So dy over dt is 2, and dy over dt is this one. So we insert this here. So since y equal to 50 over x, we substitute for this one, and we get this, and we solve this, so we get the final equation. So for the question A, they want to know for the 5-inch, meaning that when our x is equal to 5 inches. So by using this formula, we just insert the 5 into here. So after that, we calculate it as usual by using calculator, and we get this. So this means the perimeter is decreasing because of the sign of the negative. So for the B, it's same like A. They want to know, the question want to know if the x equal to 10 inches. So we just insert like the previous one, and but this one we can got the positive one, meaning that the perimeter is increasing. So for part C, so this one, the question asks, when does the perimeter stop changing? So this happens when dp over dt equal to 0. So we take the dp over dt, this one, the final equation, just equal it to 0. So we can solve this like usual. this one, we move into here and we get this and just square this side and we get 5 squared 2. Yeah, and after we get the x value, we need to know for the y value also, because we need to know when the parameter stop changing. So after we know both value, we can know that parameter stops decreasing when dimensions same, also minimum when the rectangle becomes a square. This means by the y value and x value are the same.
So now I would like to explain you guys about this question. What should be the daily output to obtain a maximum total profit? First of all, we have the total cost function is Cx equals to Rm 1 over 4 x squared plus 35x plus 25 is the total cost. And then we have the price per set is Rm 50 minus 1 over 2x. So we need to revenue is calculated as x cross p x equals to 50x minus 1 over 2x squared. So the profit we need to rx minus cx, and then we got this. And then the and then we got px equals to 50 x equal minus 3 over 4 x squared minus 25. So we substitute this equation with p prime x equal to 0. So 15 minus 3 over 2x equal to 0 minus 3 over 2x negative equals to negative 50, and then we got x 10 set per day. This is the maximum of the x. And so average cost is given by ax equal to cx over x more than 10. So the equation is ax equal to 1 over 4 x squared plus 35 x plus 25 over x. So we got 1 over 4x plus 35 plus 25 over x. So we need to differentiate this equation to a prime x equal to 1 over 4 minus 25 x squared. So a prime x equal to 0. So we can find the x, and then we got x is 10. So this is shown. So we go to second derivative. So a prime x, we can do a second derivative. We got 50x minus 3. So 50 over x power 3. So we we substitute the x with 10, so we got 0.05. So has a prime 10 equal to 0 and a second derivative 10 more than 0. So the cost per set is relative minimum at 10 at x is 10.
Okay, so hi everyone. Today I will explain about question number 4, which asks us to evaluate each of the following limits using L'Hopital's rule. Okay, so L'Hopital's rule can be applied when a limit gives an indeterminate form such as 0 over 0 or infinity over infinity. Okay. So the rule states that we differentiate the numerator and denominator separately, then take the limit again.
Okay, so for the question number 1 Roman, the equation is limit x approaches to 0 sine 3x over 4x. So when x approaches to 0, sine 3x goes to 0 and 4x also goes to 0. So this limit is in the determinate form, which is 0 over 0. So therefore we can apply the L'Hopital's rule, which means we differentiate the numerator and the denominator. Okay, so the derivative of sine 3x, we can get 3 cos 3x, and then the derivative of 4x is 4. So we will, after we differentiate, we will substitute the x approaches to 0, so which means x is equal to 0. So we will substitute the x into this equation, which is 3 cos 3 0 over 4. So we will get 3 cos 0 over 4. So cos 0 is equal to 1. Okay, so we will get this one, and then we will get the answer 3 over 4. So the limit x approaches 0 sine 3x over 4x is 3 over 4. Okay, so for the second one, the 2 Roman, the equation is limit n approaches to infinity 3e to the power of 2n over 4n squared. Okay, so as n approaches to infinity, 3e to the power of 2n goes to infinity, and the denominator 4n to the power of 2 also goes to infinity. So we will get indeterminate form, which is infinity over infinity. So we can apply the L'Hopital's rule. First we will differentiate the numerator and denominator. Okay, so for the derivative of 3e to the power of 2n is 6e to the power of 2n, and the derivative of 4n to the power of 2 is equal to 8n. Okay, so after we differentiate, we will substitute the infinity to this equation, and we will get also infinity over infinity. So we will differentiate for the second differentiation, which is 6e to the power of 2n. The derivative will be 12e to the power of 2n, and the derivative of 8n will become 8. So we will substitute the infinity to the n, because n is equal to infinity. Okay, so this one we 12e to the power of infinity over 8, we will get infinity over 8. As n approaches to infinity, the exponential term e to the power of 2n grows much faster than n, so the expression still goes to infinity. So the final answer for this question is infinity.
Right now I will explain for question 4.3. The question is limit x power of 2 multiplied by ln x. So from here, x power of 2 becomes 0 and ln x become negative infinity. This is for identify the indeterminate form. So like this one. Alright, I rewrite in fraction. So it will be like this. Then as we can see, ln x equal to negative infinity, and 1 over x power of 2 become infinity. So here we apply the L'Hopital's rule. So lim fx will be divided by lim gx. So like this one, 1 over x will be divided by negative 2 over x power of 3. Alright, so we have to simplify the expression. So I bring the bottom to beside, so it will become like this form. And then after I multiply this, it will be negative x power of 2 divided by 2. And then when I change the x to 0, it will becomes like this. So the answer is, so this one 0 power of 2 divided by 2, and then the answer is 0. So for question 4, limit n e power of 2n. So before we apply any special rule, we have to check the limit by substituting infinity into the expression, like this one. So as n towards infinity, n approaches to infinity, n towards infinity, e power of 2n approaches e infinity. So result will be infinity multiplied by infinity. So we rewrite as a fraction back, like this one. Now we see the numerator is infinity and the denominator is 1 over infinity. This is still not the standard L'Hopital form, so we have to moving the other part. So we write back like this one to get the infinity divided by infinity form. So after we rewrite like this one, we get infinity over e power of infinity. So we get infinity over 0, which is still infinity. Then we differentiate by using L'Hopital step. So we just differentiate like this. Limit n approaches to infinity, 2e power of 2n divided by negative 1 over n power of 2, and then we can get this this answer. So we can combine them like this one. Limit n approaches to infinity, 2e power of 2 2n divided by negative 1 over n power of 2 equal to this one. So we can get the final answer. Limit n approaches to infinity, 2n multiplied by e power of 2n is infinity. Usually